Right, so we've been introduced to some new differentiation techniques which seriously enhance the complexity of the expressions that we can differentiate now compared to AS, namely the chain rule, the product rule and the quotient rule. We've done a bit of practice with those, but I haven't been overly concerned about how much practice, because we'll be continuing to apply those rules with further complicated expressions, because we're now going to practice or look at differentiating specific types of functions today, namely the exponential function and the natural log function, and then beyond that in weeks to come looking at differentiating trig functions and inverse trig functions as well. But for today we're just focusing on exponential and natural log. Now in A level you've already met binomial expansion, which allows you to take an expression to a power and write it as an increasing sum of powers. An area of maths is no longer part of advanced maths, but you quite possibly will meet it in undergraduate studies, depending on the courses that you follow, are what we call power series. And it can be shown, and you will discover that there are a large number of power series where certain functions can be written as increasing powers of x. And one such function is the exponential function. And it's a really neat way of showing what happens when you differentiate e to the power of x. So this is the power series for e to the x. It can be written as 1 plus x plus the square of x over 2 factorial plus the cube of x over 3 factorial, and so on up to infinity. Factorial, I hope you know from other work, is so 3 factorial would be 3 times 2 times 1, 4 factorial 4 times 3 times 2 times 1, and so on. So depending on how accurate you want your value of e to, say, 1, so if you wanted to work out e to the 1, you would replace the x with 1. So it would be 1 plus half plus a sixth, and so on. And as I said, the more terms you include in it, the more accurate it becomes in comparison to the true value of e to the power of x. So it's a really sort of amazing comparison, really, that something like the exponential function can actually be written just in terms of powers of x. Anyway, if we consider differentiating that, so what we're going to do is differentiate e to the x with respect to x. And if we differentiate this side, well, when we differentiate 1, it's a constant, we get 0. When we differentiate x, we get 1. When we differentiate 2x, we get 2x, and that will be over 2 times 1. When we do the third term, it'll be 3x squared over, and 3 factorial is 3 times 2 times 1, which is the same as 3 times 2 factorial, plus 4x cubed over 4 times 3 factorial, and so on to infinity. So when we tidy that up, do our cancelling, the 3's cancel, the 4's cancel, what we end up with is that when we differentiate e to the x and we differentiate its power series, we get 1 plus x squared over 2 factorial. So can you see what's happening here? We end up with the same power series, which means that when you differentiate e to the x with respect to x, you get e to the x. So differentiating e to the x gives you e to the x. Now you don't have to prove that, but you do need to use that, and it isn't something that you're given in the formula book. So you need to learn that. So what that means now is that in conjunction with our chain rules and quotient rules and product rules, and this, it now means that we can differentiate even more functions and expressions than we could previously. So we'll work through EG13 shortly.